Hello, and welcome to Mr. Jackson's chemistry class. Hey, we've been working on this unit on chemical reactions, and we've talked about formulas and writing chemical reactions and all the information we can include as well as the indicators. We've been talking about balancing chemical equations and reactions, and we've been talking about the diatomics, and then just the other day we just got done doing the balancing and all the possible ways we can look at how to balance a chemical reaction, because there's no one way to do that. So today I want to jump down to the categories or classifying chemical reactions, okay? And so there are 5 basic categories that chemical reactions occur in this level of chemistry. There are a lot of other categories. I don't want to tell you there's only 1 or 5 types, okay? But this is what we're going to learn for this first year chemistry course, okay? And these are our 5 categories. Our 5 categories are called synthesis, decomposition, single displacement, double displacement, and combustion, okay? They're not very hard to understand. Synthesis is simply another idea of combining things together. So synthesis, when you synthesize something, you combine, because sometimes it's called combination reactions. And all you're really simply doing is you're taking multiple materials and you're combining them together into a larger material. Okay? You could even take a compound, A, B, things that are already joined together, and add something else to their structure. So you could end up having an even bigger structure. So this is just generic letters. I'm not picking any exact equation, but to give you an example of one of these, I could use one. We could take hydrogen and oxygen, and we are making water. That would be an example of a synthesis type reaction. Maybe one like nitrogen and hydrogen go to make ammonia, okay? And so that would be another combination type reaction, all right? So I just want to give you one. Decomposition is actually just the opposite of synthesis. It's when things decompose. And so that means it just breaks down. Okay? And it's not hard to visualize. You have a material, and these are very easy to recognize. There is nothing, there's no plus sign on these sides of the reaction, on the reactant side, because there's nothing to react with. So these can't get any bigger. The only thing I can do is just basically break apart. And there's a lot of materials that do break down. So I just want you to understand that that is an example of, a decomposition reaction. So let me try to find one here. I have a list of reactions over here. So giving you a decomposition one would be here, potassium chlorate turning into potassium chloride and oxygen. So potassium chlorate, which is KClO3, breaking down into potassium chloride and oxygen. Okay? So this one would be something like ABC. Now remember, no plus sign, breaking down into an AB and then a element, but it's been breaking apart. So that's still decomposition. Okay? Pretty easy to understand. Okay? The next category is called single replacement. And displacement is what this book uses. I'm used to replacement. But single displacement just means that one element is being displaced. Okay? So you would have, in simple generic terms, you would have something where you have a compound, and something is in elemental form, and that element is more aggressive than one of these 2 elements, and so what it does is it pushes its way in, and now it is reacted and combined with another element, and then the other element that it replaced is kicked out. So that's why I call it single displacement. Okay? And that's not hard to understand. I'll give you an example one. Here is magnesium, and when you put magnesium into an acid, HCl, okay, what happens is the magnesium is very aggressive. It attacks the hydrogen, and it ends up making magnesium chloride, and then the hydrogen is displaced or kicked out and bubbles are formed, and so then you have a displacement reaction. Okay, so see, you have an element. Okay, I just have switched them around, and there's no correct rule for which one gets written first, the element or the compound. But the element attacks the compound and makes a brand new compound, and that one of those that were in the compound to begin with are now turned into an element form. Okay, that's single displacement. Well, double displacement is just 2 times that. Okay, so we have double displacement. Double displacement is not difficult. It's just when you have 2 materials, so A, B plus C, D. And what happens is sometimes they call these ion exchange reactions. So there's other places that name them differently. But what happens is these are positive and negative ions, and we've been making formulas all along, but they want to switch partners with each other. And so the A somehow lets go of the B and grabs onto the D, and they rebond, and then the C bonds with the B, but we have to put the C first because it's positive. And so what's happened is 2 things. It's kind of like square dancing. They've just switched partners and formed brand new materials. And these are easy ones to see. Let's just take something like barium phosphate. Okay, is Ba3PO42 plus hydrogen sulfate, H2SO4. And what happens is these ions switch partners, so the barium hooks up to the sulfate, BaSO4, plus, and then H2 and H hydrogen bonds to the phosphate, H3PO4, okay, and forms those 2 materials. So it's called a ion exchange, but mostly a double displacement is what we're going to call that, and that's the main idea of what's happening here. Okay, and the 5th type is combustion. And combustion is pretty simple, I believe, because what it is it's basically the burning of combustible materials, such as hydrocarbons. Hydrocarbons, and now where we've been putting letters A and B just to represent generic elements, we don't know what they are until we draw it out. But this one only occurs with specific elements. So I'm going to kind of change up how I'm writing it. I'm not going to use my A, B, C letters. We're actually going to write how it may look. This is written this way. Okay? And so what happens is we have a hydrocarbon, something that's mostly hydrogen carbon, that is broken down or burned with oxygen, and they always make CO2 and H2O. Those are the consistent products every single time with combustion reactions. So let's look at an example of one. Let's go with propane, C3H8 plus O2 goes to CO2 plus H2O. But be careful, these don't always have to have just carbon and hydrogen. They're just mostly carbon and hydrogen. Sugar or sugars, tree sugar, sucrose sugars, lactose, amylose, all kinds of different sugars that are out there, they're sweeteners, have a similar chemical structure. So the one you learn in photosynthesis is C6H12O6. That's a hydrocarbon. Okay? And if you could eat it, hydrocarbons you can eat are called carbohydrates. So what happens is then you breathe oxygen in your body, and your body gives off CO2 when you breathe and H2O out of your body. Okay? And so that's what we do as humans. We use carbohydrates, which is still a combustion reaction. Okay? So this is what I wanted you to know about that. And so I've got them right here. There's their generic forms. Okay? And so I want you guys to be able to recognize reactions as either synthesis, decomposition, single displacement, double displacement, or combustion. And you need to recognize them in symbol form in this way and know what categories they belong to. Okay? So we're going to be doing that today on your worksheet. Thank you for joining me. I appreciate it.